We're going to find the area between two curves when we need to break it up into two separate regions. The first thing that I want to do is to graph these so I can get a good idea if I want to integrate with respect to x or if I want to integrate with respect to y. So let me move over here into Desmos, and I'm going to go ahead and type in my equation. So x is equal to y cubed minus 10y plus 8. And then enter, I'll just get another empty cell, and then x plus y equals 8. It doesn't give me the best viewing window, so I can go ahead and adjust my viewing window here just a little bit to get a better view. I also added some shading, and you can see that I've got two different regions, the one up above in green and the one down below in orange. This gives me three different intersection points that I'm going to need to find. Desmos, if they're nice numbers, will do a really nice job of that. I can go ahead and click on these points of intersection, and I can see exactly or almost exactly what they are. There's that one. And then here is the third one. But I also need to determine if I'm going to integrate with respect to x or with respect to y. To determine which variable to choose, x or y, to integrate with, I'm going to go ahead and set up my rectangle so that the length of the rectangle, whether it's upright or side by side, the length of the rectangle goes from one curve to the other. In order to do that, it is not going to work to do it in this direction. Instead, I need to draw my rectangles in this direction. So now I've got my rectangles so that they take the rightmost function minus the leftmost function as the length. And then you can see that this width is in the y direction. So my width is equal to a dy. Because I've determined that y is going to be my variable of integration, I want to make sure that both of my equations are functions with x on one side in terms of y, so everything in terms of y on the other side. The first function is all set up, that one's ready to go. To get the other function in the form that I need it, I just need to subtract a y from both sides. So for that second function, we're going to use x is equal to 8 minus y. So now I've got both of my functions, and I want to go ahead and find mathematically the points of intersection. We're going to use the y values from my points of intersection as our limits of integration. To do that, we're just going to set both of our functions equal to one another. So I end up with y cubed minus 10y plus 8 is equal to 8 minus y. To solve this cubic, I want to get 0 on one side. So I'm going to subtract the 8 and add the y and add the y. This gives me y cubed minus 9y is equal to 0. I can factor a y out. That gives me y squared minus 9 in the parentheses, which, if I factor this one further, is going to be a difference of squares. Y plus 3, y minus 3 is equal to 0. This is going to give me the three y values where my two functions intersect. So those three y values are, y could be 0, that would make this entire product 0. In the second factor, a negative 3 would make that product 0. And in the third factor, a positive 3 would make that equal to 0. Now that I've got my limits of integration, I'm ready to set up my integral. Let's go ahead and identify each of these on my graph here. So negative 3 is the lowest value, 0 is going to be the middle, and then up here I've got a y value of positive 3. So I've got two different areas here, and I'm going to call this one area 1, and let's call this one area 2. So as I'm setting this one up, we're going to do area 1 first. Area 1 is equal to, I'm going to do this in pink, so area 1 is equal to the integral from, I'm going to go up now, so negative 3 to 0, making sure everything is in terms of y. So that's going to be negative 3 to 0, and I want to take my rightmost function and then subtract my leftmost function. My right function is the curve, so that's going to be my y cubed minus 10y plus 8 minus my line, which is 8 minus y. And all of this is dy plus I have a second integral, and that's going to represent a2. My second integral representing a2 is going to be the one in green here. So it's going to go from a y value of 0 up to a y value of 3. Those are my limits of integration, 0 to 3. This time, my rightmost function is the line. So I'm going to start with 8 minus y, and I'm going to subtract the curve, which is y cubed minus 10y plus 8. And then this is all dy. Let me give myself a little more room, and we'll keep working through the integral. Let's start by simplifying this first integral. In the first integral, I have, let's see, the integral from -3 to 0. I'm going to just start working my way through y cubed. There are no other y cubed, so that one's going to stay. I have a -10y, and then negative times negative y, that's going to be plus y. So -10y plus y is -9y. And then I've got my 8 minus 8, those cancel. And this is my first integral, and I leave the dy there. That second integral, the second integral goes from 0 to 3. As I work my way through this one, I have the 8, but I've got a -8 here, so those cancel. And then I've got the negative y. The negative y is going to combine with negative times -10, so negative y plus 10y. So I get a, let's see, that's going to be a 9y. And then finally, I've got that minus y cubed. So minus y cubed dy. I am ready to integrate. So let's go ahead and start integrating this first one. I get y to the 4th divided by 4 minus 9y squared divided by that new power 2. And this is going to be evaluated from -3 to 0 plus, very similar in the second one, I get 9y squared divided by 2 minus y to the 4th divided by 4, and that's going to be evaluated from 0 to 3. Now, both of these antiderivatives that I need to evaluate have y's in all the terms. So when I use the fundamental theorem of calculus, and that's going to give me f of my antiderivative f, evaluated at 0, minus the antiderivative evaluated at -3, when I put 0 in, I end up with just a 0. So this goes away. Similarly, I've got over here plus the antiderivative evaluated at 3 minus the antiderivative evaluated at 0. When I put 0 in, again, y is in every term, so this is going to go away. So instead, I'm going to go ahead and evaluate negative. Let's go ahead and put -3 in here. So that's going to be -3 to the 4th divided by 4 minus 9 times -3 squared divided by 2. And then our second one, so in green, I'm going to evaluate everything now at 3. So this is going to be 9 times 3 squared divided by 2 minus 3 to the 4th divided by 4. Okay, so what do we have? I have that negative sign out in front, but each of these, because one's to the 4th power and the other one's squared, each of these are going to become positive in those fractions. So I end up with a -3 to the 4th is 81. So -81/4. I'm going to distribute that negative. So I get plus 3 squared is 9. So I get another 81, but this time it's 81 divided by 2. In the next expression, I get a 9 times 3 squared. So that's going to be another 81. So this is plus 81 divided by 2. And then plus 3 to the 4th times a negative, so I get -81/4. As I am simplifying this, I am just about to my answer here. Let's go ahead and combine what we can combine. I've got an 81/4 here and another -81/4. That gives me 2 -81/4. You can, of course, do this in Desmos or in your calculator. And I also have 2 of those 81/2. Now I'm anticipating needing a common denominator. I'm going to cancel this 2 here, and I get -81/2 plus, I'm going to leave the 2 here. 2 times 81 is 162 divided by 2. I've got my common denominator. Do that subtraction. and I get my answer of 81 halves. You guys are doing so great. Take a look at this next video, which is going to walk you through volumes. Thank you so much for watching.